Okay, we're back for the second part. We'll finish up everything in this next video for section 2.2, working with normal distributions. And again, finding the areas in a normal distribution. So we're going to kind of work on that a few different ways using technology and some calculations. So all normal distributions are the same if we measure units of size of the standard deviation from the mean. Okay, so if we always base it on that, they'll always have that same area. So that's kind of key as we're kind of looking at that. But so basically to find that z-score, remember back in there, to find that, we're going to take the actual value, subtract the mean, and divide by the standard deviation. So there's your little formula that we need for that to standardize that score. So the standard normal distribution would have a mean of 0 and a standard deviation of 1, and so that curve would look just like that. But obviously, we're going to see some different means and standard deviations, but that's what it would look like. So again, how do you find the area in any normal distribution? You can draw, so go just draw your bell-shaped curve with the horizontal axis labeled and scaled using the mean and standard deviation. All right, and then just make sure that the boundary values are clearly identified and that the area of interest, what we're asking, is shaded. So you can do this a couple things. You can standardize each value and use table A, which is our Z table, or we can use some technology in order to do that. So don't be afraid to watch that technology corner video to show you kind of the steps on how to do that. It's always a good reference to go back in case you forget. And then, of course, you can use technology to find the desired area without standardizing. That's another way that you could certainly do that as well. So just always make sure you go back and answer the question that was asked. Okay, and again, make sure to write complete sentences. So let's go back to this. Distribution of the Iowa Test of Basic Skills vocabulary scores among Gary, Indiana 7th graders. Recall the distribution, it was approximately normal, and the mean was 6.84, and our standard deviation was 1.55. So we want to know what proportion of these 7th graders have vocabulary scores that are below 6th grade level. Okay, so here's what we're going to do. We're going to draw that normal distribution, horizontal axis labeled, okay, so using the mean and standard deviation, and then we're going to get those boundary values clearly identified, and we're going to make sure we shade that. So this is kind of what we're looking at right here. Okay, so with that score, we can kind of figure this out. We can get that z-score and then figure out what that is. Okay, so again, standardize each boundary value and use table A or technology to find the area under that normal curve. Okay, and then we could use technology as well. So if we look at this, we got that z-score of negative 0.54. That's telling us we're negative 0.54 standard deviations below the mean. So again, we go to that z-table and we're going to look right here. This is negative 0.53, negative 0.54. That's what we're looking at right here. So we kind of get that table down. We're able to kind of get that in where they cross. So it would be right here. So that's going to be 0.2946. In other words, about 29.5% would have vocabulary scores below that 6th grade level. So again, and again, we can type that into the calculator as well. Look at that. Look at that as well. Look at that technology corner to know how to do that. All right. So again, make sure to answer the question. So once again, complete sentence, right? We got to write those out. So we estimate about 29.4. I rounded mine to 5. Probably not a big deal. Of Gary, Indiana 7th graders score follow below the 6th grade level on that Iowa Test of Basic Skills vocabulary test. So that's what we have there. Now, how do you find values from areas in any normal distribution? Kind of working backward here is what we're doing. And so we're going to draw that normal distribution, label it, of course, with mean standard deviation, mark the area of shaded interest of area, of interests, of course, and then the unknown boundary clearly marked. We're going to see what that is. So again, and then we do the following. Okay, we use that table A or technology, and we can unstandardize that score, and then of course we could always use technology to find that without even standardizing. So, and again, make sure to answer the question that's being asked. So here we go. So this time we have the heights of 3-year-old females are approximately normally distributed. The mean is 94.5 centimeters, standard deviation of 4. So we know at 75. We want to figure out 75% of the 3-year-old girls are taller than what height. So basically, we're going to have to find that 25th percentile, because remember, that's the percentile that is greater than or equal to 25%. So if we want 75% above, we'll have to find that 25th percentile. So again, we're going to have to mark that up. Again, here's the mean. We mark down those standard deviations. All right, and we know that, you know, the 25th percentile is going to be right about here. Remember, 50% is here. You know, we'd have 68% in between here, so another 34. So somewhere around in here. Yeah, we're not exactly sure. We'll kind of figure that out. So a couple ways to do that, then, of course, is to show some calculations. Now, again, from Table A, we can kind of figure out that if we take a look at that 25th percentile, we can go to that 0.2500. We're going to find the z-score of negative 0.67. Now, again, we can type this in the calculator to do the inverse normal. Now, again, the area that we want, since we're looking at 75% above, we're at the 25th percentile with the mean of 0 and standard deviation of 1, of course. And then we can use that, so it's understandardizing it to get here. Now, when we get that number, that z-score, all right, notice we don't have the actual score here, but we do have the mean and the standard deviation. And so just a matter of multiplying by 4, adding the 94.5, and we see that that actual score is 91.82. So any height that's at that or above, we would say certainly 75% of those would have to be the score there. So, or, you know, like I said, we could always do this here. The 0.25, you could always put in the actual mean and standard deviation. Boom, boom, boom. That actually works out really easy, doing it with the calculator. And again, look through those keystrokes with that tech corner. They'll walk you through that, and you'll see exactly how to do that. Or come see me. I can certainly help as well. All right, now make sure we answer the question again in complete sentences here with our picture. We can say about 75% of 3-year-old girls are taller than 91.8 centimeters. And again, notice the label, very clear, complete sentence. Okay, is what we're looking for. All right, so again, this is all the things we're doing in Chapter 2, and that kind of ends our chapter. We'll talk a little bit more about assessing normality, kind of looking at whether a distribution of data is approximately normal or graphical to finish up this section. And then, of course, we'll get ready to go for our Chapter 2 test. So, all right, so lots of stuff to throw at you. Get working on those assignments. Until next time, I'm Mr. Boone.